Hi, I'm Rich Breckner with Inside HPC. We're here at ISC 12 in Hamburg. I'm here with Josh Simons from VMware. So Josh, you've had this mission of being this evangelist for virtualization technologies in HPC. It's about the 2-year mark. Where are we at with it?
Yeah, it's a good question. So we are about 2 years into this. I joined just over 2 years ago, and it's actually pretty interesting. We're starting to see some real traction in terms of interest for HPC and virtualization together. It's coming not from this community, the community that you'd see at ISC typically or at SC in the US, but it's coming from our customer base. And it turns out that a lot of the customers that we have at VMware who have a lot of virtualized infrastructure also have a pretty significant amount, in some cases, a pretty significant amount of HPC workload as well. These would be like EDA customers, life sciences customers, digital content creation. So some of the sort of throughput-oriented verticals within HPC, they've actually been coming to us, and I'd say over the last 6 to 9 months, we've seen a pretty significant uptick. And that actually has really started to kickstart some interesting things within the company in terms of solutions to address those. At the same time, and I talked about this earlier this week at the advisory council meeting, we're not content to really deal just with throughput applications. We're also looking at low latency and how we can potentially offer InfiniBand in a virtualized environment.
So why would I want to do virtualization? We're in the HPC world. Things have to go fast. Isn't virtualization slow?
Yeah, so that is probably the single biggest misconception. There are a lot of people that did testing maybe 3 or 4 years ago around virtualization and looking at the impact from a performance perspective. That was before sort of the Nehalem class and similar class systems from AMD, and before, frankly, a lot of advances were made in the virtualization technology itself. So we're at the point now where if you're running straight line code on a virtualized system, that runs at essentially full speed. I mean, you're really, again, compute is going to run totally at full speed because there's no emulation going on there. You're running directly on the hardware with nothing between you and the bare metal. It's when you start running things that are incur latencies, things like I/O, that actually, especially latency-sensitive I/O, where you potentially will see some overheads in the platform. And depending on how sensitive you are to latency, you'll see a larger or smaller effect in terms of performance. But bare metal performance for a lot of throughput applications is in, say, the 1 to 5% at most range, and what you get back for that. So the question is, you're going to give something up, what do you get back? And we've developed a set of use cases in talking to a lot of customers over the last couple of years that really, for a lot of customers, speak to them in terms of offering them higher efficiencies and more flexibility in their IT infrastructure.
So let's break that down. I mean, what kinds of features of virtualization are they using in the cloud, in the enterprise, that could be of real benefit to these HPC users?
Oh gosh, right. So the ability to easily wrap up a software stack and put it into a catalog, and then on demand instantiate that as, say, a virtual cluster and environment, is something that allows easy support for multi-tenant environments. So you might have different research teams at a commercial entity or at a research organization that want to spin up different clusters, so we can offer them the ability to do that with totally different software stacks. Now you can do that in a bare metal world using some of the typical HPC provisioning systems, but we can go beyond that as well. We can use things like live migration, which is the ability to dynamically move workload from one physical machine to another without stopping it, and use that to do some bin packing of running workloads so that we can get much higher efficiencies in terms of overall resource utilization. You can use the virtual machine abstraction to offer protection, so you can do security protection between workloads if you have, say, a multi-tenant environment. You can also use it for fault protection. You can also use the snapshotting capability as a pretty comprehensive checkpointing capability, and we're thinking about definitely a vision statement. We're looking at the potential of coupling fault detection or fault prediction with live migration, so that you can imagine in a future scenario where you're running on a large-scale environment that's experiencing lots of hardware failures, if we could actually predict an upcoming failure on a box and then proactively live migrate a piece of your MPI application off of that box before it fails, then you avoid having to take the full checkpoint of exabytes or petabytes of main memory state, and you essentially dodge the failure as you're running forward. That's sort of a far out use case, but the other use cases around more efficient use of resources and the flexibility are really what are driving customer interest at this point.
So Josh, kind of a wrap up here. What would you say are the challenges in front of you now? Is it technological or is it more perception? How would you weigh that?
Yeah, I'm going to say both, actually. So for the HPC, that sort of dyed-in-the-wool HPC community, there's definitely a perception issue. Now, having said that, so the perception is that, as you said, that there's a significant performance hit for all HPC applications. And so the message there is it's only partially true, right? So that some aspects, MPI, which is clearly an extremely important part of HPC, will see some slowdowns. And so the biggest challenge for us is, can we drive those latencies down to the point where we're able to offer more value to the customer than we're taking away with the performance reduction?
Well, great. Well, hey, Josh, I know this is very close to your heart, and congratulations. I think you've made tremendous progress, and keep up the good work.
Yeah, thanks a lot, Rich. We're having a lot of fun.
You bet. You bet. Okay, that's it for the Rich Report. From Hamburg, I'm Rich Breckner. See you next time.